Hi everyone, my name is Bhavishya, and in today's lecture we will learn about RIP version 2. So in the all previous lectures of RIP version 1, we have learned how RIP version works, what are the properties, what are the boundaries, and now we'll understand RIP version 2. But before that, let us take an overview of our RIP version 1. So our RIP version 1 was a classful routing protocol. That means it is totally dependent on the receiver to investigate and determine whether to consider the sending sended address as network, subnet, or a host. So what was happening? Let's suppose in sender sends the IP address and receiver receives the IP address. After that, it will determine by comparing its existing subnet mask on one of its interfaces. Then by that it will determine whether to take it as subnet, whether to take it as network, or whether to take it as host. But in RIP version 2, it is classless intra-domain routing. We will understand this fully in a bit with a good example. But for now, we can learn it via saying that in RIP version 2, we have subnet field. So this is why we call it classless. Okay, so let's understand. So when we look at the RIP header, RIP version 1 header and RIP 2 version header, they both are same. But when we talk about the route entry, FI zeros in IP address, and here it has 0. But in the RIP version 2, we have subnet mask field, right? So let's take an example where we will fill these entries to and we'll understand the entries. Now here, if you look at this topology, here if we used to apply RIP version 1, so here RIP 1, router 1 is sending the information of this network to our R2, right? See how the entry looks like. See how the route entry looks like when we are using RIP version 1. So R1 is sending to R2 this information. R1 has learned this network because it was directly connected, and now it is advertising it with this IP address and with matrix of 1. This is what was happening in RIP version 1, right? But in RIP version 2, as now we have the subnet mask field, this is what it will going to send. Along with the IP address, it is sending subnet mask. So now R2 is getting, okay, the network I'm receiving is subnetted, right? The matrix is 1. So this is one example. Let me take another example. Now here in this topology, as you can see, when we apply RIP version 2, this is what R1 is advertising to our R2. Look, R1, so here as you can see, R1, so R1 is directly connected to R3, so it knows 172.16.10.0 and will advertise it with a hop count of 1. So as you can see here, the IP address and subnet mask, right? As we are dealing in RIP version 2 and matrix having 1 as it was directly connected, so it will advertise with a hop count of 1. Now, when we talk about 30.0.0.8 network, so it is one hop far from R1. So it is going to advertise it to R2 with a hop count of 2. So this is how RIP version 2 is performing in this topology. Let me take more examples to make RIP version 2 clear to you. Now we have another example. So this problem, that the topology we can see, this is a disk contingency problem when we used to look at it with the eyes of RIP version 1. Okay, but here let's apply our RIP version 2. Okay, so as you can see, R1 is going to advertise R2 about this network, right, with this subnet mask. and along with direction, right? How direction? Because when we'll see in show IP route, see, it will say, I've learned this IP address on on this this network on via this fast Ethernet, right? So it is telling us the direction that okay, if we look at the look with the router's two perspectives, so it is coming from the left side of the network. Similarly for this, so what R3 will advertise about this network with this subnet mask along with the direction that it has learned through this network on this fast Ethernet, right? So it is also telling us with the perspective of R2 that the network is coming from the right side of the R2, right? So this is how our discontinuity problem is solved when we use RIP version 2. Now, now via this problem we learned that this property of RIP version 2 is known as CIDR, that is classless intra-domain routing, not interdomain, intra-domain. When we talk about intra, that is when we're talking about within the network. And we talk about inter, then we are talking about two or more than networks or outside of the network, right? And also when we talk about RIP version 2, so it is the best use case of VLSM, that is our variable length subnet mask. But also R1 also use it, but as long as the subnet mask on the different interfaces over the network are symmetrical, then only. If not, then you know better. And also, when we talk about, let's suppose, when we talk about this problem, we also in our routing entry here after subnet mask, we also have one more new field. Before we had zeros here, right? Now we have a new field in ref version 2. Surprise. That is our next hop. So let's suppose if when I take example of this network, let's suppose R1's this network. According to you, what will be the next hop? Naturally, if you want to answer, you will answer that 20.0.0.1, right? This one. This is a very natural answer. But in this case, this is not the answer. The answer will be 0.0.0.0. Now let's understand why we use this and what is the significance of it. Now when we use in R2, we'll type this command show IP route. This is what it will show, right? And this is what we were supposing to have in our next hop. Mm, and now we are not having it. We replace it with this. Now, when we talk about this network, how this is learned, right? This is a question. So this is being learned via our Ethernet frame. When R1 is sending our, our RIP packet to R2, it is sending through Ethernet frame, and inside that Ethernet frame we have source IP and destination IP. From there it is learning this network, right? So in next hop, this particular address 0.0.0.0 means nothing has changed. That means that the next hop is the same that we received in while we learned this address. So this particular is saying that this is coming from the same place as it was coming when we learned the IP address. So this signifies nothing has changed until we replace it with a different IP address until we uh, man until we modify it manually. And let's take an example how we modify when we modify it and what is the use case. Now here in this topology, when we configure it with RIP version 2, this is what we'll have, right? So there are two paths, as you can see. The very first is if R1 wants to, let's suppose, learn about 20 network, about this network. So the best path is this, right? As the hop count is just one. And the other path is via R2. But here the hop count is 2, right? This path. So when we configure it with RIP version 2, this is what it will display us because this is the best path. And for entries for this will be for R3, this is the entry. And via R2, this is the entry, right? And this is what it will show us. We are learning it via this network on this interface. Right. Now, let's suppose I deconfigured, I reconfigured our R3 and I removed the RIP configuration with this. Now what will happen? Now here, let's suppose I have removed R3 from the configuration of RIP, right? And now PC1 wants to communicate to PC2, right? Before this was the path via this R3. Now the best path we have is via R2. So for that, this is what the output will look like, right? It is learning about 20 network with hop count of 2 via this path on this interface, on this, right? But as a network engineer or but as a network administrator, we know that if we want to have an efficient network and if we want to have a best shortest path, I want to have the shortest path. And if you look at here, the shortest path is this R3 with hop of 1. So I will go and in the next hop, I will remove this and I will entry this, right? So the next hop for best hop or the best shortest path will be this. So after this configuration, what will happen? Initially, this was the entry, right? But after this, the entry will be this. It is learning about 20 network with hop count of 1 via this IP address on this fast Ethernet. Right. So what is happening here is R1 is receiving RIP update, right, from R2. Before it was before the next hop was this, and we were having this entry, right? But after we manually configured about the best path with this hop count, what is happening is when it is reaching to R2 asking about 20 dot network because this is not configured with RIP, right? So it is reaching R1 is reaching R2 and asking about this network. Now R2 is saying that don't ask me about the 20 network, else go to R3 on this particular hop and you will find it, right? So before it was this, right? And now this is this after we manually configured it. So this is the user R this next hop and we use it when it is as nothing has changed. So this was the concept of reversion 2. I hope you enjoyed. See you in the next one.